Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to discuss chapter number 5, chemical bonding, part 1. In this part, we will cover formation of chemical bonds, type of chemical bonds, ionic bonds, characteristic of ionic compounds, covalent bonds, single covalent bond, double covalent bond, and triple covalent bond, and characteristic of covalent bonds. Now, formation of chemical bonds. The force which holds the atoms together into molecules or a crystal is called a chemical bond. All the substance exists in the form of compounds and mixture. It indicates that there must be some force that holds atoms together in a molecule or a crystal. The nature of forces holding the atoms in a molecule or crystal is electrical in nature. The electrons in the outermost shell of an atom are called the valence either of the three forces. Number 1, complete transfer of electrons. Number 2, sharing of electrons. And number 3, coordinating or by the other types. Combination of atoms of different elements in result in the formation of molecules of compounds. Now, types of chemical bonds. The first explanations of the nature of chemical bonds were advanced by W. Kossel, a German scientist, and G. N. Lewis, an American chemist, in 1916. They proposed two major types of chemical bonds. Number 1, the ionic or electrovalent bond, by the transfer of one or more electrons from one atom to another to form ions. Number 2, covalent bond, a bond that results when atoms share electrons. Other types of bond include metallic bonds and hydrogen bonding. Now, ionic bond. In this type of combination, there is a complete transfer of one or more electrons from one atom to another. The atom that transfer electrons get positive charge, and the atom that gains electrons gets negative charge. The strong electrostatic force acting between positive and negative ions holds them together. The attraction that binds oppositely charged ions together is termed electrovalent bond or ionic bond. For illustration, let us consider the combination of sodium and chlorine. Sodium having symbol Na and chlorine atom having symbol Cl to form common salt, that is sodium chloride or NaCl. Sodium has 11 electrons and its configuration is 2:8 and 1. When it loses electrons, it forms sodium ion having 2 and 8 electrons. Chlorine having 17 electrons and its electronic configuration is 2. K shell contains 2 electrons, L shell has 8 electrons, and M shell of chlorine has 7 electrons. It gains the electron of sodium and becomes chloride ion, that is Cl negative, having electronic configuration K2 L8 M8. Na positive bonded with Cl negative by a strong electrostatic force of attraction. They both have oppositely charged ions, so they are held together by a strong electrostatic force of attraction. Now, the outermost shell of sodium contains 1 electron and the outermost shell of chlorine contains 7 electrons, having 3 lone pair and 1 unpaired. Sodium loses its electron and chlorine gains the electron of sodium and becomes chloride ion. Sodium, after losing electron, sodium form Na positive ion, that is sodium ion. Here are the examples of some more compounds which form ionic bond, that is potassium fluoride. Potassium has 1 electron in its valence shell and fluorine has 7 electrons. When potassium loses its electron, fluoride ions will form after the gaining of electron of potassium. Number 2, lithium chloride. Number 3, magnesium oxide. Magnesium has 2 electrons in its valence shell and oxygen has 6 electrons in its valence shell. Magnesium loses 2 electrons and oxygen gains its 2 electrons to form oxide ion, and magnesium form +2 magnesium ion. Number 4, calcium chloride. 1 calcium atom loses 2 electrons. 1 chlorine requires 1 electron, so it requires 2 chlorine atom to give its both 2 electron. So the formula of calcium chloride is CaCl2. 1 electron goes to this chlorine atom and the second electron goes to the second chlorine atom, from calcium to chlorine. Number 3, potassium oxide. Potassium has 1 electron in its outermost shell. When it reacts with oxygen, oxygen atom has 6 electrons in its outermost shell. Each oxygen atom requires 2 more electrons. So, it reacts with 2 atoms of potassium. 1 potassium provides 1 electron to oxygen and the second potassium provides second electron to oxygen and form potassium oxide. Now the characteristic of ionic compound. In ionic bond, it is impossible to say that any 2 ions are bonded to each other to produce molecule. But in the crystals of ionic compounds, the positively charged ions are mutually surrounded by each other in orderly arrangement. Thus, ionic compounds are solid at room temperature. Ionic compounds have high melting and boiling points because of the strong electrovalent bonds existing between the ions. Ionic solids do not conduct electricity as the ions are not free to move. Once an ionic compound is melted or fused, the ions are free to move and conduct electricity. Similarly, solutions of ionic compounds conduct electricity. Ionic compounds are usually soluble in polar solvent, that is, solvents of high dielectric constant, such as water, but ionic compounds are insoluble in nonpolar organic solvent. These solvents have low dielectric constants such as benzene, carbon tetrachloride, etc. They are mostly inorganic compounds. Now, covalent bonds. The shared pair of electrons which links the atom in a molecule is known as covalent bond. In covalent bond, the shared electron pair is commonly expressed by single short line. For example, the halogens chlorine atoms possess an electronic configuration in which there are 7 electrons in their outermost shell and lacking only 1 electron in order to attain the structure of an inert gas. This structure may be attained by the halogens molecules, chlorine molecule, when both atoms share 1 electron for bond formation. 1 electron from this chlorine atom and the second electron from this chlorine atom. Single covalent bond. In single covalent bond, only one pair of electrons is shared by the bonded atoms, in which each atom must share 1 electron. This type of bond is represented by single short line. For example, in the formation of H2 and HCl molecule, only one pair of electrons is shared. Formation of Cl2, single covalent bond, and formation of HCl. HCl molecule has one hydrogen atom with 1 valence electron and one chlorine atom with 7 valence electrons. In this case, a single bond is formed between hydrogen and chlorine by sharing 1 electron. Double covalent bond. In double covalent bond, only 2 pairs of electrons are shared by the bonded atoms, and each atom must share 2 unpaired electrons. This type of bond is represented by 2 short lines as shown in the molecules of O2 and carbon dioxide. Example, carbon dioxide molecule has 1 carbon atom with 6 valence electrons and 2 oxygen atom with 4 valence electrons. To complete its octet, carbon shares 2 of its valence electron with 1 oxygen atom and 2 with another oxygen atom. Each oxygen atom shares its 2 electrons with carbon, and therefore there are 2 double bonds in CO2. Oxygen molecule. In the formation of the oxygen molecule, each oxygen atom has 6 electrons in their valence shell. Each atom requires 2 more electrons to complete their octet. Therefore, the atoms share 2 electrons, each to form the oxygen molecule. Since 2 electron pairs are shared, there is a double bond between the 2 oxygen atoms. Ethylene molecule. In ethylene, each carbon atom shares 2 of its valence electron with 2 hydrogen atoms and remaining 2 electrons with the other carbon atom. So there is a double bond between the carbon atoms. Remember, the bond between carbon and hydrogen is a single covalent bond. And here, the bond between the carbon and carbon is a double covalent bond. Now, triple covalent bond. A triple covalent bond is formed when 3 pairs of electrons are shared between the 2 participating atoms. Triple covalent bonds are represented by 3 dashes or 3 lines and are the least stable types of covalent bonds. For example, in the formation of nitrogen molecule, each nitrogen atoms having 5 valence electrons provide 3 electrons to form 3 electron pairs for sharing. Thus, a triple bond is formed between 2 nitrogen atoms. Characteristic of covalent compounds. Compounds with covalent bonds are usually made up of discrete units or molecules with a weak intermolecular forces. In the solid state, there are weak van der Waals forces between the molecules, hence covalent compounds are often gases, liquids, or soft solids with low melting points. In few cases, three-dimensional covalent structures are formed rather than discrete units. Hence, diamond and silica, that is SiO2, are covalent but are very hard and have high melting points. Usually, covalent compounds have low melting and boiling points. They are insulators because they do not conduct electricity. Number 4. Covalent compounds are usually insoluble in polar solvents like water, but soluble in organic solvents like benzene or ether. Thank you very much. Allah Hafiz.